Hello, hello. Good evening, student. Am I audible and clearly visible? In today's class, I will start from the here. In last class, I have done this question of moment of inertia, in which the three masses are given 1, 2, 3, and these masses are kept at a distance of a. Follow the equilibrium triangle, and we have need to find the moment of inertia about this. About this axis 1 and this axis 2. So, I easily find the moment of inertia about this axis, and let us say I1, and about this axis we say I2. I think this is clear to all of you. Now, I am going to study the new concept, how to find the moment of inertia of continuous mass system. Clear? Moment of inertia of continuous mass system. What is continuous mass system? In the previous class, we have studied about how to find the moment of inertia of discrete mass system, like 1, 2, 3, 4 mass are distributed along the or toward along the axis. But in this moment of inertia continuous mass system, in which the mass is distributed continuously from the axis, like the first is rod, like this is the axis which is moving with the angular velocity omega, and this is the rod, and the rod having mass L and length mass m and length L, and you have need to find the moment of inertia of this rod, and we have need to find the moment of inertia of this rod about the given axis. Clear? Understand? In the previous class, we have studied how to find the moment of inertia of discrete mass. How to find the moment of inertia of discrete mass? Simply by using the formula I is equal to mr square, in which m is the mass of the object and r is the perpendicular distance of the object from the axis of rotation. This is the formula. By using, we able to find the moment of inertia of the discrete distributed mass about the axis. Clear? Now, in this slide, moment of inertia of the continuous mass system, we are able to find the mass which are continuous from the axis. Like you can look here, this is the rod which are continuous from the axis from here to here. And in the previous class, we have only studied about the one formula I equal to mr square, which are the formula help to find the mass of the discrete system body. But by using that formula I equal to mr square, we can find the moment of inertia of this rod. How we can find? Then you can simply look here. First of all, take elementary cut from here dx length. Clear? Dx length, elementary cut, and we can find the mass of this ds object by using simple geometric method. In mass m, this is the mass of the rod. In mass m, the length of the rod is L. In unit mass, this become 1 by L. So, in dx length, mass will be L upon m dx equal to dm. So, you can look, we are easily find the mass of this dx cut part of this rod. Now, we can simply apply the moment of inertia. You can look here, we can assume this is the point mass, which are located at distance of x from this axis, and then what is the moment of inertia in this point mass about this axis? Simply this is the a small mass dm. So the moment of inertia of this dm mass will be very small, di. So we can write it as a di is equal to dm, and the perpendicular distance from here to this point is x. So we can write here dm x square. Now you can usually look here, if we cutting start from here to here, to here, then dx start from here to here, then moment of inertia at this point will be 0, and the cutting at this point length is 0. After we go from here to here, the length is L and moment of inertia become I. L. I think this is clear to all of you. Now we can do the integration. Moment of inertia of di is equal to I from 0 to I, and here we can put the value of dm. What is the value of dm? L by m into no, sorry, just we have done some mistake here. In L length mass is m, in unit length mass is m by L. So in dx length mass is m by L into dx, and this is the mass of the dm. So we put here the value of dm, m by L dx x square, 0 to. Now we put upper minus lower limit, I minus 0 is equal to I, and m by L integration of x square dx 0 to L. So this become I is equal to m by L into x to the power 3 upon 3 0 to L, and after simplify this equation, m I equal to m L square by 3, and this is the value of the moment of inertia of rod. This is the value of the moment of inertia of the rod about the axis having mass L, mass m and length L. If the rod is uniform, this is uniform rod. If the rod is uniform and the mass of the rod will be m and length is L, then the moment of inertia of the rod about the one end of the rod moving about the given axis is I is equal to m L square by 3. I think this derivation is clear to all of you, and I hope all of you understand this derivation and equation. Clear? Now you can remember this result. We can write it in simply I is equal to m L square upon 3, and I hope all of you will remember this important result. Clear? Now I am going to find the moment of inertia of the second case of this rod. Second case of this rod, means this is the axis. The axis is moving with angular velocity omega, and this is the rod. This is the rod. The rod having mass m and length L. Now the rod, the axis is passing from the middle of the rod, means from here to here, length is L by 2, and here to here the length is L by 2. I think this statement is clear to all of you. In previous question, the rod is the axis is passing from the one end of the rod, either from this end or this end. The moment of inertia become m L square upon 3, but in this case the axis is passing from the center of the rod. This is the center of the. Clear? Then how I will find the moment of inertia of this case? So simply we can find similarly. We go and take the elementary cut from the distance x this is dx, and simply find the mass of dx. So we can calculate it as in L length mass is m, in unit length mass is m upon L, in dx length mass is m by L dx equal to dm. I think this is clear to all of you. Now, similarly, by the previous concept which we use in this question, simply we use here, this is a point mass about this axis. So we can find the moment of inertia of this point mass. I is equal to, for point mass, moment of inertia is very small. So let us say di is equal to mass dm, and the distance from here to here is x, so x square. But you can look here, in the previous case mass started from here and end here. So we started the limit from here to here is 0 to L, but in this case mass started from here to here and also from here to here. So in this case mass started from here to here. So we can say that this is the origin. So this become L by 2 in minus, and this become L by 2 in plus. So mass start from here to here. So minus L by 2 to L by 2, and moment of inertia from I to, simply we integrate this di, this value become I, and we put the value of dm. The value of dm is m upon L dx, m by L dx into x square minus L by 2 to L by 2. So after that I is equal to, take the constant outside, and this become x square dx minus L by 2 to L by 2. Now I is equal to m by L, and this become x cube by 3 minus L by 2 to L by 2, and we put here m by L cube upon 24 minus, and minus come outside, plus here also L cube by 24 after calculating. And now you can calculate the final result is m L square upon, this is the very important result which I derive. You should remember this result also, this result also. So in today class we have derived two results: the moment of inertia of the continuous object, this is the rod, and the moment of inertia of this rod about this axis is I is equal to m L square by 3. You should remember this result. This result will be used many time in the incoming lecture. So remember this result, no? And in this case the moment of inertia of the rod, the axis passing from the middle of the rod. In the middle of the rod, the value of the moment of inertia is I is equal to m L square upon 12, where m is the mass of the rod and L is the length of the rod, m L square upon 12. I think this is clear to all of you. This is clear to all of you. Clear? Now I am going to find the moment of inertia of some special cases, like this is the axis and move with omega, and the rod is lying on this axis. The rod having mass m and length L. Then what will be the moment of inertia of this rod about this axis? Now you can clearly look here, the axis and the rod are lying on the same line. So the perpendicular distance of the rod from the axis is 0. Perpendicular distance of rod from axis is 0. So I is equal to m and distance is 0. So 0 square. So I is equal to 0. And this is the value of the moment of inertia when the uniform object or a discrete mass or point mass, anything which are passing from the axis, if they are passing from the axis, then their perpendicular distance from the axis is 0 and the moment of inertia I is equal to m into perpendicular distance square, but perpendicular distance square from the axis is 0. So the net moment of inertia will be 0. I think this is clear to all of you. Clear? Now the second case is that this is the axis moving with, and this is the rod having mass m and length L, and the axis making an angle theta with the rod, or rod making the angle theta with the rod, or the rod making an angle theta with the axis. This is the condition. Clear? This is the condition. Then what will be the moment of inertia of this rod about this axis? Now we can simply easily find the what will be the moment of inertia. Simply we go at x distance from here and we take the elementary cut, and we can find the perpendicular distance of this elementary cut will be this one, and simply by geometry we can find what is the length of this. So simply we can apply, let us say this is y, and we say sin theta is equal to y by x. We say y is equal to x sin theta, this is x sin. Clear? I think this is clear to all of you. Now you can look here, the perpendicular distance of this point mass from here to here is x sin theta, and what will be the mass of this dx length? Simply in length L, mass is m in 1, mass is m by L in dx, mass is m by L dx, and let us say this is dm. I think this is clear to all of you. We are able to find the perpendicular distance and mass, then simply we can put in the formula from here to here and solve the question easily. Like di is equal to dm L square, means x sin theta, but this is the perpendicular length, no? So 0, so I, and what is dm? dm is m by L into this one. So we can put here 0 to, and this become I, and we put here dm. What is the value of dm? m by L dx x square sin square theta 0 to L, and after calculation you can find I is equal to m by L sin square theta, and the integration x square dx is x cube by 3 0 to L. Simply we can put here, and after solving you look here, m L square sin square theta upon 3, and this is very important result. This is very important result. The moment of inertia of the rod making an angle of theta with the axis, when the uniform rod of mass m and length L making an angle theta with the vertical axis, then the moment of inertia will be I is equal to m L square sin square theta upon 3. I think this is clear to all of you. Now you can look here, this is clear to all of you. And one case which can this is the one case we can try here. Case number 5 is that this is the axis and the rod making an angle theta and passing from the center. The rod is passing from the axis is passing from the center of the rod, but rod making angle theta with the axis, and the rod having mass m and length L. Then what will be the moment of inertia of this rod is I is equal to m L square sin square theta by 12. Clear? I think we done this here because you can look here when the rod making an angle 90 degree with the axis and passing from the center. In this case, I is equal to m L square by 12, but makes an angle passing from the center. The modulus is m L square sin square theta by 12. Clear? This one. Clear to all of you. Now we have in today class study about the how to find the continuous mass system. In continuous mass system, we have able to find the moment of inertia of the object. First one continuous object is this is the rod, and we can how we find the moment of inertia of this rod. I is equal to m L square by 3 when the rod is when the axis is passing from either the one end of the rod, mass m and length L, then I is equal to m L square by 3. I think this is clear to all of you. Now, and this is a derivation. This is the second case in which the mass m and length is L of the rod, and the axis is passing from the center of the rod. Clear? Center of the rod. In this case, the moment of inertia I is equal to m L square upon 12. But in this case, axis is passing from the center of the rod, but rod is making angle theta with the axis. In this case, moment of inertia is I is equal to m L square sin square theta upon 12. I think this is clear to all of you. In the third case, when the rod is passing from coincide on the axis, in this case the perpendicular distance from the axis is 0, so the moment of inertia I is equal to 0. In the fourth case, when the rod when the one end of the rod making an angle theta with the axis and the rod having mass m and length L, then the moment of inertia of the rod about the axis I is equal to m L square sin square theta by 3. I think this is clear to all of you. This is clear to all of you. Clear? Now I am going to find the moment of inertia of the other geometrical figure like ring. Clear? I am going to find the moment of inertia of the ring. So you can look here. This is the ring, and this is the radius r of the ring, mass m and radius r. Mass of the ring will be r and radius is r. Now my target is to find the moment of inertia of the axis, this axis, which is this is the axis perpendicular to the ring. Clear? And this ring lie on the board. Means this ring is lie on the board and axis, this red axis is perpendicular to this ring, means in this way. Clear? Means this is the plane and this is the axis, a ring is in this way. If the ring is moving like clockwise or anti-clockwise direction, let's say, then we have need to find the moment of inertia of this ring about the given axis. This is the axis and ring is moving in this way. This is the ring movement, like moving in this way about this axis, about this red axis. Then how I will calculate the moment of inertia of this ring? And you can look here, this is the ring which are distributed continuously in this way, uniform body. Then process is same. How I will find the moment of inertia of this ring? Simply we go and cut elementary cut d theta of this part, dx, let's say dx, and we say that similarly we find, first of all we need to find the mass of this dx part which cut as elementary part about this axis. Then how I will find? Similarly, this is the complete length of the circle and the complete circumference will be the complete length of the circle about this axis, and this will be 2 pi r, and in 2 pi r the mass is m. In unit mass is 2 pi r, clear? But in dx length the mass is m by 2 pi r into dx. I think this is clear to all of you. And let's say this is dm. So we are easily able to find the mass of this dm. Let's say this is the mass dm which we cut. Now we can easily find the moment of inertia of this object. This is the distance r from here to here. So di is equal to dm r, and clear. Now if we start to cutting the string from here and cut in this way, cut, then we start from here and complete move one round of 360, then come here and completely cut this ring in a small part. So at this point moment inertia is 0, the angle is 0, but here to here we continuously move, then the moment inertia complete will be I, and the moment is 2 pi. Now we can integrate it. This is I and this become dm. What is the value of dm? Is m by 2 pi r dx into r square. This becomes 0 to 2 pi, and this become I, and cut down r to r, this become m r upon 2 pi outside, and this become 0 to 2 pi dx. But you can look here, the limit in the form of angle, but here the function is dx. So first of all we have need to convert this dx into this one, like this is the length dx, this is the length dx, and this is r, and this is the theta d theta. Then we have already studied about d theta is equal to dx upon r. So what is dx? Dx is equal to r d theta. So we can put here I is equal to m r upon 2 pi, and in the place of dx we put r d theta from 0 to 2 pi, and after integrating this you will find I is equal to m and m r square upon 2 pi, and the integration of d theta is theta, and the limit is 0 to 2 pi. After putting the limit you find 2 pi minus 0 2 pi, and 2 pi cut down, so I is equal to m r square, I is equal to m r, clear? I is equal to m r square. Now you can look here, what is the moment of inertia of the ring? You can remember this important result, I is equal to mr square. This is the value of moment of inertia of the ring. This is the value of the moment of inertia of the ring about an axis which are passing from the center of the ring, and the axis will be perpendicular to the ring. This red axis is perpendicular to the ring, and this axis is passing from the center of this ring. Remember, this axis is passing from the perpendicular of this ring. Clear na? This is perpendicular to of the ring. And what will be the moment of inertia of this ring about this axis? Which axis is perpendicular to this ring? I is equal to mr square. I think this is clear to all of you, and I hope all of you understand this derivation very easily. Simply we first of all take the elementary cut of dm mass and find the mass of the dm. In this way, 2 pi r in complete length 2 pi r, mass is distributed m. In unit mass is distributed m upon 2 pi r. In dx cut part, mass will be m upon 2 pi r dx, and this will be the mass of this small cut part dm. And simply we use the formula I is equal to mr square. How to find the moment of inertia? Simply in a small part the moment of inertia is small, so di is equal to a small m into perpendicular distance from the axis. This is the perpendicular distance from the axis, and after that we take the complete length of this ring dx. So we have need to move 0 to 360 angle. So we move 0 to 360 angle, and the net moment of inertia become 0 to I. After that we put the value and solve the this derivation, and we find the final result I is equal to mr square. I think this is clear to all of you. Clear? Now we have need to add sub slide. Now we have need to we have added the slide. You can look here. This is the ring. We have able to find the moment here of the ring about the axis which are passing perpendicular to the center of the ring. Now in the incoming lecture we have able to find the moment of inertia along the diameter of the ring. Clear? So just wait, and now just one thing is that this is the axis and this is the arc of ring, and the mass is m and length is radius is r. This is the radius r, and what this is perpendicular. No, this is perpendicular. This is arc of ring. Then what will be the moment of inertia of this arc of the ring? Simply I is equal to mr square, because this part having the mass m and the perpendicular distance of this ring from here to here is r. So simply the moment of inertia will be I is equal to mr square. And also the other type, I think this is clear to all of you. Like the second case is that this is the this is the semi ring, and this is the semi ring having mass m and radius r, and this is the axis which are perpendicular to this semi ring. Then same the moment of inertia I is equal to mr square. I think this is clear to all of you. This is clear to all of you. This means that if the ring is complete or the ring have the some part given arc or the semi ring, in every case the moment of inertia about the axis which are perpendicular to it is I equal to mr square. I think this is also clear to all of you. No, clear. Now clear. Now we are going to find the moment of inertia of the disc about an given axis. So this is the disc. This is the disc, and this is the axis. We make axis with the blue line, and this axis is perpendicular to disc, and disc is lie on this blackboard, no? And this axis is perpendicular to this, and the mass of the disc is m and radius is r. Then how I will find the moment of inertia of this disc about the given axis? Then this is also a simple observation. You can look here by taking the elementary cut at a distance x from the center, like in this way. Clear? This is the elementary cut of dx length. No, this is elementary cut of dx length. Then how I will find the moment of inertia of this disc about this axis? Then first of all we take the elementary cut of this disc, and this at a distance x from the origin, and this look like this one. This is look like ring, and I already know the moment of inertia of the ring about the axis. What? I is equal to mr square. I is equal to mr square. So this is the very small ring. So the moment of inertia for this small part is di, and this become di is equal to dm, and from here to here distance is x square. This is already we have studied in the previous slide, in the ring slide. Here I equal to mr square means m is the mass of the ring and r is the perpendicular distance of the ring from the axis. Similarly here the perpendicular distance of the ring from the axis is x, so the di is equal to x, and simply we have need to find the dm, and we can able to find the moment of inertia of this disc about the axis. Then how I will find? Simply we can find, you can look here, this is the disc, na? This is 2D surface. So in complete pi r square surface, mass distributed is m. So in unit mass distributed is m upon pi r square. So what is the area of this strip? You can take this strip and come here. This is the strip, no? So you can cut here. The strip look like this one, no? Like a rectangle, and this is the length 2 pi x, and this is the dx. So the area of this strip is 2 pi x dx, and in 2 pi x dx area the mass will be m upon pi r square 2 pi x dx, and this should be dm. So you can cut down pi to pi, the net this will be m 2 m x dx by r square, and this will be dm. I think this is clear to all of you. Now we can easily put here the value of dm. First of all, we put the limit from here to here. We cut a small ring from center to here, from 0 to r. So at 0 the moment of inertia is 0, and after cutting from here to here the length cover R, the moment of inertia will be I. So this is I and this become dm. What is the value of dm is 2mx dx, 2mx dx upon 2mx dx upon r square into x square 0 to r, and this become I is equal to, take outside, 2m upon r square, 2m r square, and this is x cube dx. So after solving 0 to r, this become 2m by r square into r4 by 4. So cut down r square and 2 to 2, and this become I is equal to m r square upon 2. This is your final result, I is equal to m r square by 2. So you can just remember this result, I is equal to m r square by 2, and this is the moment of inertia of the disc. This is the moment of inertia of the disc about the axis which are passing from the center of the disc, and perpendicular to the disc. The axis which are passing from the center of the disc and the axis is perpendicular to the disc, then the moment of inertia of the disc I is equal to m r square by 2. The disc having the mass m and radius r, then I is equal to m r square upon 2. I is equal to m r square upon 2. I hope all of you understand this derivation, and all of you understand this derivation, and you should remember this result. This result directly used in the incoming question which I have done. This result will be directly used. So please all of you remember this result. Whatever I derive in the today class, the moment of inertia of the rod about the axis from the one end ml square upon 3, from the center ml square upon 12, making angle theta with the edge ml square upon 3 sin square theta. Moment of inertia of the ring from the center perpendicular to the ring is mr square. Moment of inertia of this disc passing from the center mr square by 2. You should remember all the result, because these result directly used. So I hope all of you will remember this result. Clear? Now I am going to discuss the more part of this. Now you can look here, like this is the axis and this is the cut part of disc. Like this is the complete disc, but cut part means you can just understand this is the like the one part of pizza, having mass m and radius r, and this is perpendicular, this axis is perpendicular to this cut part. Then what is the moment of inertia? Simply the moment of inertia I will be I equal to mr square by 2. Clear? The moment of inertia is mr square by 2. I think this is clear to all of you. Clear? This is clear to all of you. So now I am going to move about the moment of inertia of the other object, like solid sphere. Like solid sphere, now I am just writing this, the result of this and you all of you should remember this result. No, if you want to derive this result, then I can hint it in brief. You can look here, this is the mass m and radius r, and this is the solid sphere. This is the solid sphere. The moment of inertia about this axis is what? I is equal to 2 by 5 mr square. 2 by 5 mr square. Clear? The moment of inertia of this solid sphere I is equal to 2 by 5 mr square. Clear? If someone come and say me, ask from you what is the moment of inertia of the, this is the semi solid sphere having mass m and radius r, simply I is equal to 2 by 5 mr square. I think this is clear to all of you. 2 by 5 mr square. Clear? This is also a solid sphere. Solid sphere na, topic is solid sphere na. How I will you will find the moment of inertia? You do 2 by 5 mr square. Simply take the elementary cut like this one, and this become the disc, and from here to here up in downward direction you feel you have got the many discs. Then first of all you find the moment of inertia of this one disc and integrate from here to here, minus r to r, and in this way you can find the moment of inertia of this solid sphere. You can try, or you have no need of know about how to find the moment of inertia of these things, but you should remember the moment of inertia of this figure, solid sphere I is equal to 2 by 5 mr square, because this result is directly used in the question. Clear? This result is directly used in the question. I is equal to 2 by 5 mr square. Clear? I think this is clear to all of you. And now the hollow sphere. In hollow sphere, this is hollow and this is mass m and radius r. The moment of inertia of this hollow sphere about the axis passing from the center of this figure, then I is equal to 2 by 3 mr square. I think this is clear to all of you. I is equal to 2 by 3 mr square. I is equal to 2 by 3 mr square. If someone asks from you what will be the moment of inertia of this semi hollow sphere, this is the axis hollow. Simply I having mass m and radius r, then I is equal to 2 by 3 mr square. Why I am able to write the same things? Because this object have mass m and radius r, and this object, this is semi hollow sphere, but mass is m and radius is r. And in the previous class I already explained you, moment of inertia is depend on the mass distributed along the axis of rotation, means mass distributed about the axis of rotation. So a full part the moment of inertia is 2 by 3 mr square, but the half part having the mass m and radius r, so same the moment of inertia will be 2 by 3 mr square. I think this is clear to all of you for the hollow object. Clear? I think this is clear to all of you. And now I am going to study about the you can study here the hollow cylinder. What will be the moment of inertia of hollow cylinder? Simply this is mass m and radius r, hollow cylinder, then I is equal to mr square, and in solid cylinder, the moment of inertia in solid cylinder will be this axis is with omega angular velocity having mass m and radius r. This is the solid cylinder, na, solid cylinder. So the moment of inertia I will be mr square by 2. I is equal to mr square by 2. I think this is clear to all of you. No? I think this is clear to all of you. Now I am going to derive the two important theorem to find the moment of inertia of the unknown axis. No? How to find the moment of inertia of the unknown axis? For finding this, we have studied about the two important theorem, because in today's class whatever we study to find the moment of inertia of the continuous object is like that: ring, disc, a sphere, solid sphere, like that, in which all the cases the axis is passing from the center, axis is passing from the center and perpendicular to the geometrical figure, disc, ring, whatever we study in the today class. But if someone asks from you to find the moment of inertia like that, moment of inertia of the ring about this axis, or moment of inertia of the disc about this axis, no? Then how you will find the moment of inertia of this required axis? No? We have no any method till now, but if we study these two theorem, then we can easily find the moment of inertia about this axis. I think all of you understand, no, clearly. So now we can easily able to find the moment of inertia of the any axis which we have need to find. So just we study the two important theorem to find the moment of inertia is that the first theorem is the perpendicular axis theorem and the second theorem is parallel axis theorem. By using this theorem, we can find the moment of inertia about the any axis, no? About the any axis, about the diameter, about the tangent, about the whatever the axis is given in the geometrical figure, we can able to find the moment of inertia of the about the any axis, means that, no? So first of all, we are understanding the perpendicular axis theorem. Perpendicular axis theorem. You can look here. The name of this first theorem is perpendicular axis theorem. Then something you guess from this statement. This theorem is for the perpendicular axes. No? So the name of this theorem is perpendicular axis theorem. Means that, and the second thing is that this theorem is not used for 3D object. 3D object means like a sphere, solid sphere, cone. For these types of object, we do not use this one. No? We use this theorem only for ring, disc, a square sheet. Clear? Means the geometrical figure having only 2D type of shape. Like ring have 2D shape, disc have 2D shape, and a square sheet have 2D shape, a square rectangular sheet have 2D shape. So we can apply this theorem for 2D object. Apply this theorem for 2D geometry shape. I think this is clear to all of you. In this lest you understand, this is the axis. Make this axis with the separate color for easy understanding. This is the axis 1, this is the axis 2, and this is the axis 3. Let's say this is x, this is y, and this is z. You can look here. All axis, axis x, axis y axis and z axis, all three axes should be mutually perpendicular to each other. Now, clear? Means if we applying the perpendicular axis theorem, then first of all condition is that we have three axes x, y and z, x, y and z, where in this which two axes is lying along the figure whatever the moment of inertia we have need to find about the geometrical figure like disc, ring, then two axes x and y lie along that geometrical figure, and the third axis which are perpendicular to that given figure. Clear? In this case, the moment of inertia of this perpendicular z axis, this should be Iz is equal to Ix plus Iy, and you should remember this theorem, and you can easily find the moment of inertia of the unknown figure easily. Now, I will take one example and I will try to understand these things and this theorem, but important thing in this theorem is that this is applied for 2D object, and in this case three axes is required, two axes along the 2D plane and the third axis perpendicular to the 2D plane, and the condition is that I axis x, y, z, all these three axes are mutually perpendicular to each other. Here, this is the three condition you should remember, and after that you can now look here the example of this theorem is that like this is the ring, this is the ring mass, this ring having mass m and radius r, and someone come and ask from you find the moment of inertia of this ring about the diameter, means diametric end, means this is the point m and this is the axis which are axis passing from dia MET RI diametrically end. Now, means this point is the diameter, and this axis passing from the diameter, means axis lie in this place. But I have no idea how to find the moment of inertia about this axis. No, but in the previous slide we have studied about how to find the moment of inertia of the ring, the axis passing from the ring, but axis is perpendicular to the ring, means this is perpendicular, no? This is perpendicular to the ring. So simply we can find in this way, like we have need to find the moment of inertia about this I. So we can simply make at least three axes x, y, z to apply this concept. So we make this about this axis we have required to find the moment of inertia. So we make one axis which are perpendicular to this axis and lie in the same. So let's say we say this is x axis and this is y and this red line is z, then we can easily say that according to the first theorem of moment of inertia, Iz is equal to Ix plus Iy. And now you can look here, Ix and Iy, both the axis is passing from the diametrically end point, like in this way or in this way, and you can say that the moment of inertia about the Ix axis or Iy axis should be same because both the axes are symmetrical, na? So we can say that Ix or Iy, let's say I, because both the axes are symmetrical, like this is the axis passing in this way, or this is the axis passing in this way. If you just move this in this way, then this and this is symmetrical, because in this case the axis passing from the diametrical end, and in this case the axis passing from the diametrical end. If just you rotate this axis in this way, then this figure and this figure is identical. So we can say that this axis and this axis, the moment of inertia about this axis and the moment of inertia about this axis should be same. So we can say that about this axis and about this axis, the moment of inertia should be same, and let's say I. Now we can find the moment of inertia about this axis, now let's say I, but about this red axis which are perpendicular to the ring, already we have know the moment of inertia. What is the moment of inertia about the ring passing from the center and perpendicular to the ring? The moment of inertia is mr square. So we can write here Iz is equal to mr square. Why? Because the mass of the ring is m and radius is r, and Ix is equal to I plus I. So we can add here I is equal to 2I and I is equal to mr square by 2, and we can say that this is the axis about which we have need to find the moment of inertia, and this axis is y. So we can say that Iy, which are the required axis about which we have need to find the moment of inertia, and this is Iy equal to mr square by 2. I think this is clear to all of you. From today class, this is the last question, and from here I will continue the parallel axis theorem and further. Thank you to all of you. Thank you.